Hello everyone, welcome to the Fuzzing book and welcome to an all new chapter with all new research and implementation results. Today we're looking into an all new package that allows us to specify the fuzz input that we want to produce even better than with grammars. Or more particularly, we're going to add things onto grammars to make them even more powerful. So if you followed the other chapters in the book, you see that we are quite impressed with grammars, notably because they allow you to do black box fuzzing and whatnot, but they do have limitations. And these limitations come into play whenever you want to express something, well, that cannot be expressed in a grammar. We call these semantic properties in contrast to the syntactic properties that you can express with a grammar. To look into that, let's just right away look into an example. I already prepared little things, so let's go right into our notebook here. We have the book utils, and I'm going to look into the US phone grammar. We already have seen that before. Our US phone grammar, well, that's a phone number, and the phone number consists of an area followed by an exchange minus a line. Area is 3 digits, exchange is 3 digits. The line is 4 digits, and this is something that you can now use to happily produce one phone number after another, for instance, by putting this into one of our nice fuzzers. So sure, then you can produce valid, syntactically valid phone numbers. But what do you do if you want to have a phone number, say, within a specific numerical range? Suppose you want to have an area code that is between 900 and 915. You could go and do that by tweaking the grammar, for instance, by saying, oh, the area code should always begin with a 9 or something, and then the digit should either be 1, and then it should be 0 to 4. Or it should be 0, and then it can be any digit that follows. So you could, in principle, do that, but that's, frankly saying, that's a total pain in the behind. You don't want to do that. And so the question is, how can we state that we want specific numerical conditions, specific numerical constraints on these individual elements? And this is where an all-new package comes along, which was developed by the great Dominik Steinhöfel, actually a postdoc in my group. And this package is called ISLa. ISLa for Input Specification Language, and it allows you to add constraints to a grammar and also solve them. In order to install ISLa, you need to do some pip magic first. So you do pip install ISLa solver, and there you go. Well, in my case, it's already installed, so there's not much to be done. And once you've done that, you can then go and use the ISLa package, and notably, you can import what is called a solver. So you import a solver, and this solver is named the ISLa solver. There you go. From ISLa import, oh, sorry, no. That's not how you do it. You write from ISLa solver, import ISLa solver, and then you have the solver package at your hands. And now you can instantiate such a solver. The solver is the one that actually produces inputs, actually. Could also be called ISLa fuzzer, but in this domain it's called a solver. And we take our grammar, US phone grammar, there we go. And now we do something special. We add a constraint. And the constraint comes in this special constraint language. And this constraint language actually allows you to express formulas over individual grammar elements, or non-terminals. For instance, you can say that the area, this is the area over here, the 3 digits that we have up front in those parentheses should, this is a string, if we convert this into a number with the special function string to int, this should always be at least 900. There we go, and this is something we can now put into ISLa. Boom, and yep, ISLa has happily accepted that. And if we now we can get a bunch of solutions. There's an iterator which allows us to do that using solver.solve. There we go. And then we can iterate over these solutions. Say the first 10 solutions for that very thing is going to be our, not my day today, here we go, for an arranged thing. And then we go print next solution. Here we go. Great. What did I do wrong, Rex? Oh, solutions. I'm so sorry. Here we go. And now you actually get the output, and you see that, well, the output is the same as with fuzzer.fuzz, which was the syntactic version. But now this ISLa solver also makes sure that the area code is always greater or equal than 900. So it automatically addresses this constraint over here. And this is something that we can also do with other constraints. So for the fun of it, let's do that. For instance, we can say that the area should always be identical to, how do you call that? This is the exchange. So the area and exchange should always be the same. So let's make this as a constraint. These are all things that cannot be expressed in a grammar alone, having equality between two elements. There we go. And now let's copy this thing and put it down here. We again produce solutions, and we have ISLa produce all these solutions. And now you see that the area code and the exchange code actually are always the same. And you can even go and combine these two constraints. Just for the fun of it, what do we have? So we want the area code to be above 900, or, well, to be precise, to be greater or equal than 100, and we also want both of them to be equal. There we go. And now again, what we need to do is we need to get these solutions out, and then get the solutions in here. And there we go. And here we have plenty of numbers. 980, where the area code is 980, and the exchange code is on where the exchange code is also 980. Actually, since we are in a movie, let's give this real-world movie numbers. In movies, the area code is always 555, so that's also something you can write. So I want the area code to be 555, and that's what's going to happen now. If we have that, then we're going to get an error. I'm sure, yes, we get an error. Because we don't find any solution. We said that the area code should be 900 or more, but it also should be 500, so there's no solution for that. So let's take this out. And now we should be getting plenty of very, very nice movie numbers. So if you want to call me, just call me at 555-555-8734 and enjoy ISLa. In the actual chapter, you're going to see many more examples of how to use ISLa. It's a super versatile way of shaping the inputs in exactly the form you want. It's a super nice way to ensure that the locations you want to reach, that the behavior you want to trigger is exactly what you can get. And ISLa gets you an unprecedented means to exactly specify this, and then you let the fuzzer and the constraint solver, which is at the heart of ISLa, do its work. So read the chapter and enjoy. Thank you.